Good day, this is Professor Will, CBMD PhD. Today's Monday, March 30th, 2020. It is 10:31, 10 seconds a.m. Eastern Standard Time. Just taking a bit of a break from Corona. This is my lecture on Cosmology Part 2, so let's get started here. Has the time dilation of distant source light curves predicted by the Big Bang been observed? This time dilation is a consequence of the standard interpretation of the redshift. A supernova that takes 20 days to decay will appear to take 40 days to decay when observed at redshift z equals 1. The time dilation has been observed with 4 different published measurements of this effect in supernova light curves. Our galaxy is really moving away from us, or is space-time just expanding? This depends on how you measure things, or your choice of coordinates. In one view, the spatial positions of galaxies are changing, and this causes the redshift. In another view, the galaxies are at fixed coordinates, but the distance between fixed points increases with time, and this causes the redshift. General relativity explains how to transform from one view to the other, and the observable effects, like the redshift, are the same in both views. Why doesn't the solar system expand if the whole universe is expanding? This question is best answered in the coordinate system, where the galaxies change their positions. The galaxies are receding from us because they started out receding from us, and the force of gravity just causes an acceleration that causes them to slow down. Planets are going around the sun as fixed-size orbits because they are bound to the sun. Everything is just moving under the influence of Newton's laws, with very slight modifications due to relativity. Cooperstock et al. Computes that the influence of the cosmological expansion of the Earth's orbit around the sun amounts to a growth by only 1 part in a septillion over the age of the solar system, even on the much larger million light-year scale of clusters of galaxies. The effect of the expansion of the universe is 10 million times smaller than the gravitational binding of the cluster. Is the universe expanding, or is it just that our definitions of length and time are changing? The definitions of length and time are not changing in the standard model. The second is still 9192631770 cycles of the cesium atomic clock, and the meter is still the distance light travels in 9192631/299792458 cycles of a cesium atomic clock. What is meant by a flat universe? The universe appears to be homogeneous and isotropic, and there are only 3 possible geometries that are homogeneous and isotropic. A flat space has Euclidean geometry where the sum of the angles in the triangle is 180 degrees. A curved space has non-Euclidean geometry. In a positively curved or hyperspherical space, the sum of the angles in a triangle is bigger than 180 degrees, and this angle excess gives the area of the triangle, divided by the square of the radius of the surface. In a negatively curved or hyperbolic space, the sum of the angles in the triangle is less than 180 degrees. When Gus invented the non-Euclidean geometry, he actually tried measuring a large triangle, but he got an angle sum of 180 degrees, because the radius of the universe is very large, if not infinite. So the angle excess or deficit has to be tiny for any triangle he can measure. If the radius is infinite, then the universe is flat. Boyle developed this geometry and published it, whereupon Gus wrote to Boyle's father, "To praise it would amount to praising myself, for the entire content of the work coincides almost exactly with my meditations which have occupied my mind for the past 30 or 35 years. What is the universe expanding into?" This question is based on the ever-popular misconception that the universe is some curved object embedded into a higher dimensional space, that the universe is expanding into this space. This misconception is probably fostered by the balloon analogy, which shows a 2D spherical model of the universe expanding in 3D space. While it is possible to think of the universe this way, it is not necessary, and there is nothing whatsoever that we have measured or can measure that will show us anything about the larger space. Everything that we measure is within the universe, and we can see no edge or boundary or center of expansion. Thus, the universe is not expanding into anything that we can see, and this is not a profitable thing to think about. Just a Dolly's corpus hypercubicus is just a 2D picture of a 3D object that represents the surface of a 4D cube. Remember that the balloon analogy is just a 2D picture of a 3D situation that is supposed to help you think about a curved 3D space. But it does not mean that there is really a 4D space that the universe is expanding into. What came before the Big Bang? The standard Big Bang model is a singular at the time of the Big Bang, t equals 0. This means that one cannot even define time since space-time is singular. In some models, like the chaotic or perpetual inflation favored by Lindy, the Big Bang is just one of many inflating bubbles in the space-time foam. But there is no possibility of getting information from outside our own one bubble. Thus I conclude that whereof one cannot speak, thereof one must be silent. Why is the sky dark at night? If the universe were infinitely old, and infinite in extent, the stars could shine forever, then every direction you looked would eventually end on the surface of a star, and the whole sky would be as bright as the surface of the sun. This is known as Olbers' paradox, after Henrik William Olbers, 1757-1840, who wrote about it in 1823 and 1826. But it was also discussed earlier. Absorption by interstellar dust does not circumvent this paradox, since the dust remediates whatever radiation it absorbs within a few minutes, which is much less than the age of the universe. However, the universe is not infinitely old, and the expansion of the universe reduces the accumulated energy radiated by distant stars. Either one of these effects acting alone would solve Olbers' paradox, but they both act at once. Will the universe expand forever, or recollapse? This depends on the ratio of the density of the universe to the critical density. If the density is higher than the critical density, the universe will recollapse in a big crunch. But current data suggests that the density is less than or equal to the critical density, so the universe will expand forever. What is dark matter? When astronomers add up the masses and luminosities of the stars near the sun, they find that there are about 3 solar masses for every 1 solar luminosity. When they measure the total mass of clusters of galaxies and compare that to the total luminosity of the clusters, they find about 300 solar masses for every solar luminosity. Evidently, most of the mass in the universe is dark. If the universe has a critical density, then there are about 1,000 solar masses for every solar luminosity. So an even greater fraction of the universe is dark matter. But the theory of the Big Bang nucleosynthesis says that the density of the ordinary matter, anything made from atoms, can be made at most 10% of the critical density. So the majority of the universe does not emit light, does not scatter light, does not absorb light, and is not even made of atoms. It can only be seen by its gravitational effects. This non-baryonic dark matter could be neutrinos, if they have small masses instead of being massless, or it could be WIMPs, weakly interacting massive particles, or it could be primordial black holes. Good day, this is Professor Will, CBMD PhD, on Cosmology and Astrophysics. I hope you enjoyed listening and have a great day.